All right, all, we are back again in 7-6 looking at midpoint and distance formulas. Hopefully you have these on your notes, and I would highlight or notate or rewrite these two formulas somewhere. So that formula for your midpoint if you are just on a line, and then this formula for midpoint if you are in the coordinate plane. Now the nice thing about finding the midpoint in the coordinate plane is it's really like averaging. We can look at what is the total x distance traveled to go from A to B, what is the total y distance to go from A to B, and then how do I take that total x distance, cut it in half, total y distance, cut it in half, and that will lead me to my midpoint. So it's actually, and you can't see what I just highlighted, it's actually a really easy process once you practice it and get used to it. So that's the big thing, is you got to practice and get used to this process of determining that delta y and delta x. Now delta, the Greek symbol delta, looks like this, looks like a triangle. Make it a little nicer. That represents change in. So if we're discussing the change in something, we oftentimes call that our delta value, our change value. So when I talk about delta x or delta y, that is what I'm referencing. So here's our first problem. JK is a line on the number line. It has points at -12 and +4. What are the coordinates of the midpoints? Now, of course, we could say, well, how long is this line? Let's cut it in half and let's go that distance from one direction. But let's apply the formula from the front of our paper. So our midpoint formula, so we're going to say midpoint of JK here. We're not just kidding. Sorry, that was a really terrible joke. So I'm going to sum these values, -12 plus 4, and then I'm going to average. So -12, sorry, this is really hard to read on your handout. But -12 plus 4 would come out to be a -8. That divided by 2 gives me -4 as my midpoint. Now we see that -4 will actually lie 8 away from +4 and 8 away from -12. So we know that is our correct midpoint, because from there out to either of the endpoints would be 8, a distance of 8, or whatever our units are for that problem. Now our next one involves coordinate planes. This gets a little bit more tricky. So we're going to utilize that formula again from the box right on the front of your paper. So that formula, and I'm just going to rewrite the whole thing to begin with. That formula says that the midpoint is going to be x1 plus x2 divided by 2, comma, y1 plus y2 all divided by 2. So essentially we're saying what's the entire x distance, cut it in half, what's the entire y distance, cut it in half, and that's going to get me my midpoint. So for us here, we determine a point 1 and a point 2. It doesn't matter which is your point 1 and your point 2. I just always go with the order they've been given. So I'm going to say that R is my point 1 and S is my point 2. So what I set up here is 5 plus 3 over 2, comma, -10 plus 6 all over 2. So that's telling me that total span, that total distance. Hold on, give me some more screen. So now I'm going to bring that down around here, so that gives me 8 over 2. And -10 plus 6 is going to give me a -4 over 2. This gives me the point 4, -2. And if I put this into the coordinate plane, that would work out. We're essentially looking at the midpoint of like the hypotenuse, because if you think of these 2 points, if they're not straight with each other, they're diagonal and they can kind of make a right triangle. So if you think about it like that, and you go back to here, it kind of makes sense that we're trying to find this point right here in the middle of the triangle. We can find the total x distance, only go half of it, and then go up that half of the y distance. So that is both of those. So here in the next problem, I went ahead and put a coordinate grid up here so you can understand what we're trying to do. So we're trying to find an end point now. We're not trying to find a midpoint, we're trying to find an end point. So check this out. It says the midpoint of AB has coordinates 4, -9. So I went ahead and showed that right down here, 4, -9. And endpoint A, there we go. Endpoint A has coordinates of -3, -5. So I went ahead and showed A as well. It says, what are the coordinates of B? Now, what you can't see right now completely is a really nice representation that will help you think about this. If A and B are one continuous line, then I know that once A passes through M, it's going to continue on that same slope, that same path, and the same distance it's already traveled. It's going to go that same distance to get to B. So if I can figure out what my delta Y here is and what my delta X here is, I know that I'm going to repeat the same exact thing for this change and that change, which will get me to my eventual point B. So let's go ahead and figure that out. So to figure out my, I'm going to make sure that it's in the video. To figure out my delta Y, I'm going to go ahead and scroll up for a second just so you can see our values. Figure out my change in Y going from A to the midpoint. I am talking about difference, right? So I could either look at the graph and say, okay, well, I went from -5 down to -9, or I can just say delta Y is always going to be Y2 minus Y1. The change in Y is going to be wherever you ended minus wherever you began. So here, I'm going to say that my midpoint is 0.2 because I'm essentially looking at these points as 0.1, 0.2, and then B will eventually be kind of like my 0.3. So Y2 minus Y1, I set up that my Y value for my midpoint was -9, and my Y value for A was -5, so minus a -5. So my delta Y comes out to be, well, -9 minus a negative, that actually becomes plus a positive. So that is -4. So I can see from A to the midpoint, I went down by 4. And then I can find my delta X, which is my ending X value, so 4 at my midpoint, minus my beginning X value, which was -3. Now this actually comes out to be a +7 because I can see that my change in X right here, this distance from A to my midpoint, was a total span of 7. So I know that I can do the exact same thing to go from the midpoint to my final point B. So what I set up in my paper, or at least what I think about, is going from my midpoint to B. Sorry, we'll make this capital. It's going to have a change in X. Oh, my green pen is being really weird today. Alright, sorry. My change in X will be -4, and my change in Y will be 7, but what does that happen to? Well, now I need to start at my midpoint and go from there. So what I set up really, we'll just erase that since we have it above there, is I set up what my X was, what my Y was, and then I apply the change. So my X on my midpoint is, I have these right here on the paper, making sure you can still see. My X from my midpoint was 5, so 5 is going to then add 7, so my new X will be 12, and then Y is going to start at the -8 value. I think I accidentally put that at -9. Yeah, so it's wrong here on my graph. Just be aware that I dropped the point in the slightly wrong location. M should actually be right up here. So it just looks wrong, but all the math that we've done is correct. So be aware of that. That is at the wrong point on the graph. A very wrong point on the graph. Hey. So, Y, then, yeah, I was one off on both of those. My apologies. So M should actually have been shown at 5, -8, which would be right here. So take the graph with a grain of salt. It's not a great representation because I dropped that in the wrong place. But Y from the midpoint, using the math that we have, starts at -8 and then is going to decrease by 4, and that lands me at -12. Yeah, I did a little funky math on my paper because I was using the values that I had written in. No, oh, hold on. I'm getting my problem switched around. Okay, now you're all probably confused. It's okay, I'm confused also. Scarlett, I'm not going to blame you, but you came in and you threw me off. So, this problem, sorry, now you're famous, you're in this video. This problem, I do actually have this midpoint in the right place. I started looking at the next problem, so my apologies. Let's make sure that all the math we've done matches up with what it's supposed to be then. So y2 minus, so this all, I need to go back and verify that we did the right stuff here. A, the midpoint, should have been -4, should have been 7. Alright, so that is all good. Yes. Alright, sorry about that delay. So, this is what I goofed up. This should actually, we're all good except for this final step. Sorry, my original midpoint coordinate of x was 4 and of y was -9. 4 then has an addition of 7 and 9 subtracts 4. So we end up at 11, -13. So B, you can't see any of that, B is going to be at 11, -13. Sorry for the slight confusion for a moment. Now, because that process is rather complicated, go ahead and try it for these two problems. I cannot pause my video, so I'm just going to let this roll for a second, and then I will come back on here and help work you through those problems.
I won't be here next week to look at.
Okay, so I have all the rest of the notes, and I plan to file them today. So if you want the rest of them, come back whenever you want. But I doubt you're going to get through chapter 8 too fast. Yeah, so just come back whenever you want the rest, but I've got piles of notes to fill with.
Okay,
Cool. Have a good day. Alright, so keeping my problems straight, I'm going to fold my paper so I cannot dare look at the wrong thing. Everybody makes mistakes, as we've said a few times. So, same process here. I want to determine what's my delta y and what's my delta x so that I can apply that again to go from my midpoint to my new endpoint. So, I start by asking, what's my delta x, delta y? Well, to find that, I just do x2 minus x1. I have to decide a 1 and a 2 point. So I like to say that my end point is my first point, my midpoint is my second point, because then if I continue through my midpoint to my other endpoint, that would be like my point 3. So x2 minus x1, my x value from my second point is 5, and my x value from my first point is 4.5. So what we see here is that the delta x is 0.5, or 1/2. Now my delta y, going to change colors. We do our y2 minus our y1, and that y2 was originally -8, and our y1 is -2.5, and that actually becomes plus a positive, so this is really -8 plus 2.5, which comes out to be -5.5. So we now have our delta x and our delta y. All we have to do is apply that to the midpoint to move on to my endpoint. So now I'm going to say to go from my green's not working. To go from my midpoint to my endpoint, not my endpoint, I'm going to take the x that I have and the y that I have and apply the delta, the change. So my midpoint was at 5, -8. 5 needs to have 0.5 added to it. 8 needs to go down by 5.5. Sorry, -8 needs to go down by 5.5. So now my new x value becomes 5.5. My new y value becomes -13.5. So we were looking for point S. So we can now say S is at point 5.5, -13.5. So hopefully that process makes a little bit more sense this time, since I didn't mix up any numbers. We're going to do it one more time, so especially if you have not tried it on your own yet, use this process to do the same thing with t starting now at 112. You still have the same midpoint, but t now starts at a different location. We're I'm going to try to pay attention to make sure that I keep what I'm writing in the viewable space. So again, first thing I'm going to figure out is your change. So delta x, delta y. So my change in x, to go from t to the midpoint, I can kind of just look at this sometimes. To go from t to my midpoint, I know I went up by 4. And I could also just write out 5 minus 1 equals 4. I can do the same thing with my y. To go from 12 to negative 8, I know I go down by 20. But I could again follow the process. Sorry, midpoint is the second point. So negative 8 minus 12, negative 20. So there's my delta x and my delta y. So now to find my point S, I take the x and the y of the midpoint and apply the change. So my x was 5, my y was negative 8, my change is going to be 4, and my change is going to be negative 20. I get 9 and negative 28. So S, we can now say, would be at 9, negative 28. So that is how we find an endpoint when we're only given one endpoint and a midpoint. Find that change in y, change in x, and just apply it all over again.
I got out of the viewable space.
So there is the end of the solution for finding S. So now we move on to the distance formula. If you are like you identify up on the coordinate grid drawing what we're really doing. I'm trying to find the distance from point A to point B, and I look at x change, y change. What I'm really doing is looking for the hypotenuse of a right triangle. If you guys have learned about Pythagoras yet, Pythagorean theorem is one of the most important substantial theorems that we use in mathematics. It is a way that we can check if we have perfect right angles. I mean, it's just got all kinds of wild applications. It's also a pretty solid foundation of our trigonometry. So what we know is to find that distance. Let's say I call this A, call this B, little a's across from big A, across from big B. You know from the Pythagorean theorem, I'm going to replace that D. I'm going to call it C. Now you know that C squared equals A squared plus B squared, which is all we're doing. But notice they don't have B squared. This D is just itself, because to get rid of the square, we take the square root. So that's why our formula is actually, if we do this. That's the same exact formula. The square root of squared is equal to the square root of a squared plus b squared. But when I square root something squared, the square and the square root disappear. So that's how I get by itself. So remember, this is just an application of that Pythagorean formula. So to find our distances here, really looking for that delta y and that delta x first, and that happens inside of that radical symbol. So I'm going to set up that distance radical x2 minus x1 to find the change between them, plus squared, by the way, y2 minus y1. So again, I'm going to assign my points. I have a 1 point and a 2 point. So my x12 is my x1, my x0, that's 0. That's going to be easy. My y2 was 3, and my y1 was 5. Now do not be nervous. If you think we're going to get a negative number. R square the negative. It'll turn positive, and everything will work out fine for our distance. So this becomes the radical of 12 squared plus negative 2 squared, which really get rid of some of that. 12 squared is 144. And negative 2 squared is 4. This comes out to be radical 148. And the radical of 148 is not a perfect square. We see that the distance here becomes 12.16, which is approximately 12.2, since it told me to round to the tenths if necessary.
So especially if you did not try this on your own yet,
on the second one, try that
own.
I'm about to dive into the solution.
Please make sure you practice on your own. Notice I just found the distance that the x covers, the distance that the y covers, squared both of them, added them together, and then took the square root. Hopefully you are still with me up until this point. Found. And now the other thing you can do, and if you're getting pretty good at this, you can just look at this and say, what is the change in x? Go from negative 3 to 5. That takes 8. What is the change in y? From negative 4 to 5. That takes 9. So you could jump right there if you want to kind of skip over doing the arithmetic in the actual formula. But then we get the radical of 64 plus 81, and that gives me radical. Where are we? Radical 145. And that when we approximate the square root comes out to be 12.04, which is still rounded. So about 12. Perfect. So that is all of the just application on your notes. This does not. It didn't print very clearly. So I went ahead and told you the location points of Fairfield and Everett. And I'm not going to show you this whole solution. I'm just going to tell you what the answer is. And if you got it wrong, it's up to you to tell me that you either try to find your error and correct that mistake, or you got to let me know that you got this wrong and you don't know why. So my answer rounded is 9.43 is the distance between those two signals. So if you have any issue finding that, you need to let me know, and then I will create some intervention materials or something to help you figure things out. So that is the end of 7.6, the end of chapter 7. So at this point, if you have not posted in the discussion board, please make sure that you go do that, and let me know if you have any questions remaining that I can help you with. Otherwise, if your notes are done, you get your homework done, bring them in, take the assessment. Keep working hard. Have a great day, guys.